Hi everyone, and welcome to the sky this month for November 2024. My name's Paul Martinaitis, and this show is brought to you by the Astronomical Society of South Australia. So now we're entering the second half of spring. It's a fantastic time to be observing under our beautiful night skies. In particular, in the deep sky, there's some great galaxies around the constellations of Sculptor, Fornax, and Grus, which are really high up near the zenith and well placed at the moment, and we'll discuss those later on in the show. And also in the solar system, all of the planets are currently visible in one night, so it's particularly a great opportunity to look at the interior planets, Venus, and in particular Mercury, and Saturn, and is also visible in the hours before midnight. Uranus is coming to opposition this month. Neptune is still well placed from its opposition in September. And in the hours after midnight, Jupiter and Mars are also nicely placed. So we'll discuss all of those as well in the show. But as usual, we'll begin with a tour of the night sky. We'll begin by looking in the west, and we're looking at the sky as it will appear around the middle of the month at 10 p.m. in the evening, just after the end of astronomical twilight. So looking down near the horizon, we can see it's time to say goodbye to those great winter constellations of Scorpius, which is now almost entirely below the horizon, and Sagittarius, which is really low. If you want to take a last look at some of the fine globular clusters and nebula such as the Lagoon and Trifid, which are found near the spike down here, you'll certainly need to do so very early in the evening, before it disappears below the horizon. Looking a little bit further up, Parvo is well placed. There's its brightest star, sometimes called Peacock. And along with some really nice galaxies, Parvo contains one of the top 4 globular clusters to be found in the skies, the so-called Parvo globular, also known as NGC 6752. A really great object to look at in any size telescope, or indeed binoculars, and quite easy to find. Once you sweep in that region of the sky, you should be able to pick it up quite easily in a wide field eyepiece. Also, while we're looking in this part of the sky, we can see Grus, which contains a lot of galaxies, including the Grus Quartet, which we'll talk about a little bit later. And there's also two of the finest planetary nebula to be found in this part of the sky. We have here in Capricorn, not many deep sky objects in Capricorn, but certainly the best of them is NGC 7009, also known as the Saturn Nebula. And like many planetary nebula, to get an effective look at it, you need to use plenty of magnification, and it responds very strongly to an oxygen-free filter. And on a good night with enough magnification, you can see why it's called the Saturn Nebula, because it kind of has this nebulous greenish ball shape, and you can see these little ears sticking out. And it also has the interesting distinction, even though it's named NGC 7009, it was actually the first object, deep sky object, discovered by William Herschel. And that started him off on his great journey, of course, of discovering many of hundreds of others. And looking a little bit further up, we have another fantastic planetary nebula, NGC 7293, also known as a Helix Nebula, and that's in Aquarius, quite near to where you can see Saturn. And I'll just decrease that to get a better view of that. This is in contrast to the Saturn Nebula, a very large nebula. I think its diameter is roughly the same as the full moon, its apparent diameter. So you need to use relatively low magnification, and it has a fairly low surface brightness. So again, greatly enhanced by using a nebula filter. Looking in the northern part of the sky now, and this part of the sky is dominated by Pegasus, and in particular the so-called great square of Pegasus, which is really prominent when you look in this direction. And there's a lot of fine galaxies in Pegasus. But looking a bit lower down, of course, we have Andromeda. And this is a great time of year to take a look at Andromeda, which unfortunately never rises very high in the sky for us. But in the hours before midnight, we can catch it when it's at its highest point for us. So Andromeda you'll find down here, fairly easy to find because you can start at the lower right-hand corner of the Great Square of Pegasus, follow the line of stars down so you go 1, 2, and then you'll see these fainter stars coming across, and you'll find Andromeda down here, about 5 degrees away from that main star there. So the best way to find it, at least initially, is with binoculars, and it will be quite an apparent oval glow, particularly if you're looking under a dark sky. And if you want to look at it through a telescope, because of its large apparent diameter, you would need to use a fairly low magnification. And while you're taking a look at Andromeda, also look out for its companion M110 as well. And looking a little bit higher up, at the moment, also a great opportunity to take a look at M33, the Triangulum galaxy. That one also can be seen with binoculars or even the naked eye under very, very dark skies. Through my 12-inch under very dark skies, I can usually see some of the spiral structure, in particular these inner arms. And also you can usually see there's a tiny red dot that's showing up in this image. That's actually an emission nebula. In fact, it's one of the largest known. The only one that of comparable size, or perhaps a little bit bigger, would be the Tarantula Nebula in the Large Magellanic Cloud. So even though it looks like a little glow through the eyepiece, it's fascinating to realize that you're actually looking at an emission nebula in another galaxy, millions of light years away. Looking to the northeast now, we can see Orion has just appeared above the horizon. Certainly a welcome sight, beckoning in summer. So a nice opportunity to get our first view of the Orion Nebula for the season. Near Orion, of course, starts Eridanus, the river, the second longest constellation, and that snakes its way all the way from Orion across the sky, ending in Achernar towards the south. Achernar itself is now at its highest point, and Achernar is kind of always opposite to the Southern Cross. So when Achernar is at its highest point, the Southern Cross is at its lowest point. And also, if we ever want to sort of get a rough location of where the South Celestial Pole is, we can use Achernar. And what we do is we imagine a line between Achernar and Acrux, and if you go roughly halfway along that line between them, that's the location of the South Celestial Pole. So Eridanus itself, in addition, of course, to harbouring many nice galaxies, which we'll talk about certainly in a future show, it's got a couple of planetary nebula well worth looking at. The first one is NGC 1535, which is found here near Orion. That's quite a small planetary nebula, so you'll need plenty of magnification to get a good view. And when the seeing's good, in addition to seeing that outer halo, you can sometimes see an eye pattern inside, which is sometimes where it gets its name, the CBS eye or Cleopatra's eye. So, and you can sometimes see the central star as well as a bright point in the middle. Contrasted with that is another nebula a little bit further up, NGC 1360. And this has a relative, as you can see there by the relative size difference, relatively large apparent diameter, best viewed with much lower magnification. And also, for once, I think it's probably better without a filter. Try with a filter, but I find by not using a filter, it brings out that intrinsic beautiful blue color. So you'll see a lovely diffuse oval ball, and it will have that beautiful bluish green colour to it. So looking a little bit further along still again, we of course have constellations such as Dorado and Reticulum. And looking near the zenith of the sky, this is where the best objects are for this time of year, at least, all of those great galaxies, which are tending to congregate around Sculptor, Phoenix, Fornax, and Grus. So we'll just take a look at just a few of the finest ones, and I'll just show you their rough location now. So rather than doing a constellation of the month like I normally do, because there's just so many galaxies, great galaxies up in this region of the sky, I just thought I'd do a quick tour, just picking out a handful from the many tens of galaxies that I could recommend. So firstly, starting up, so there's the zenith right up here. We have Sculptor, NGC 253, which would be familiar perhaps to most of you, sometimes called the Silver Coin Galaxy. Has a huge apparent size, can easily fill the entire view of your eyepiece. So under a dark sky, you'll at least see a beautiful elongated glow with some softly tapered edges. And you'll see a little bit of it has a fairly diffuse core, I find. But provided you use enough magnification and you have a nice dark sky, you'll also see quite a bit of mottling, which represents that dust that you can see here in the photo. And you can also get an impression sometimes of these arms. So this galaxy we're seeing almost not quite edge on, it's sort of at an angle to us, which is why it has that sort of elongated oval shape. Looking further across now on the other side of Sculptor, we have NGC 55. Quite a unique galaxy. Most galaxies that we see have a high degree of symmetry, such as NGC 253 or 134, where the nucleus appears pretty much in the centre. With NGC 55, the nucleus is actually well off to one side, to the right side in this photo. So we're seeing the NGC 55 edge on. The nucleus you'll find displaced to one side. And then as you scan along it, particularly if you use high magnification, you'll see quite a bit of mottling and irregularity in the halo. And that's what you're seeing there is, again, these dark lanes, which are dust present in the galaxy. And you'll also probably notice some enhancements or tight glows or knots in the halo, and they will be these emission nebula that you can also see in the photo there. So 55 is a really interesting galaxy, worth spending quite a bit of time observing. Take your time, use plenty of magnification, and always make sure that you're well dark adapted. Looking now further up right near the zenith, we have NGC 134. Like a mini version of 253, quite a little bit smaller. So you'll need more magnification to get a good view. Again, it has that, because it's sort of partially tilted towards it or away from us, you'll have that nice sharply tapered halo with a bright nucleus in the middle. And you can also notice some subtle mottling as well, which again represents these dark lanes that you can see in the picture. Moving now down to Fornax, almost into Eridanus, we have one of the finest galaxies to be found in any sky, in any area of the sky, and that is, of course, NGC 1365. Great galaxy, one of the easiest to see the arms. So usually you can always see the nucleus, and then under a dark sky, it's not too hard to see the bar, which sort of cuts across in this direction in the photo. And then off the end of each bar, if you've got a nice dark transparent sky and you're well dark adapted, it's usually fairly easy to see these arms coming off the end. It kind of looks like a Z sort of shape in the eyepiece. One warning though, All of these galaxies do need a dark sky to see them at its best, but NGC 1365 in particular is totally destroyed by light pollution. So if you try and look at this galaxy under a city sky, even through a large telescope such as a 12-inch, I find generally you can only see the core and maybe a hint of the bar. So this is one that definitely needs a dark sky to see it at its best. Finally, when we're in this part of the sky, we can't miss looking at the Grus Quartet. There's a lot of fine galaxies in Grus, but the Grus Quartet are certainly the best of them. Like many of the objects discovered in our southern skies, they were discovered by James Dunlop in this time 1826. So great objects to look at. If you've got a wide enough field eyepiece, you can usually just fit. You can easily fit the 3 in here, but you can usually just fit in, if you've got a wide enough eyepiece, the 4th one as well. And one thing you'll notice as soon as you look at it, even if you don't see any detail in the galaxies themselves, you'll clearly see their different orientations, which makes it such a fantastic view. In my opinion, there's only one thing better than looking at galaxies, and that's seeing a group of galaxies together. And in this case, it's particularly nice because you can see their different orientations quite clearly in the eyepiece. So we'll now take a look at the lunar calendar for November. So now that we're near the end of spring, of course, true darkness is starting to begin quite late. So on the 1st of November, darkness began at around 9:20 and went through to around 4:40 in the morning. By the end of November, we'll have to begin around 10 p.m. in the evening and go through to about, and we can go through to about 4:12 a.m. in the morning. So the dark sky period where the moon won't interfere with our observations, that begins on around the 20th of November and will go through to the 3rd of December. And the moon phases are: new moon was on the 1st, first quarter will be on the 9th, full moon will be on the 16th, and last quarter will be on the 23rd. So there's a lot going on in the solar system this month. So we'll begin by looking at the interior planets. So firstly, Venus, which I'm sure you've noticed has been dominating our early evening skies for the last couple of months now, and it will continue to do so during November and well into December, shining at a blinding magnitude -4 or so. Also, Mercury begins the month fairly low in the early evening horizon, but then as November progresses, it'll move higher and higher in the sky towards Venus, and it will reach its maximum elongation on the 16th of November, where it'll be approximately 23 degrees away from the sun. So that's pretty much as large as it gets. So mid-November is an excellent opportunity to spot Mercury. So easiest way to spot it is wait until the evening sky around middle of November. Once the sun is set, you'll notice Venus quite high in the sky, very bright. Somewhat under it will be, towards the sun, will be a reddish sort of fainter star, and that'll be Mercury. Now swinging around to look at the outer planets. So firstly, in the early evening sky, we have Saturn and Neptune, both planets having recently just passed opposition, Saturn a few months ago and Neptune in September. So both of these planets are, again, very well placed to take a look at the moment. And we'll talk a little bit more about that shortly. Now looking at the remaining 3 outer planets. So these will be later in the evening or the early morning hours, past midnight. Firstly, we have Uranus, which comes to opposition this month on the 17th, and will transit at about 1 a.m. in the morning. And then we also have Jupiter, which is now only less than a month away from opposition on the 8th of December. So already it's about 47 arc seconds in diameter. So great time to be looking at Jupiter and the associated events with its moons. And we also have Mars as well, and that's will be nice to take a look at, mainly with the naked eye in the hours before dawn. It's around 10 arc seconds in diameter at the moment, so probably still a little bit small to view details through a telescope. But as we approach its opposition in January, the prospects for seeing detail on Mars will become considerably better. So something to look forward to as we get into December and January. Now looking into the early evening sky, so as we saw, Neptune and Saturn are both well placed. So Saturn is transiting at around 7:45, and it's only a couple of months past its opposition, so it's still got quite a good diameter of around 18 arc seconds. And Neptune transits an hour later at 9:15, has an apparent diameter of 2.3 arc seconds, and it's only a month past opposition. And both planets, Saturn is still in Aquarius, and you can see Neptune there is still found roughly in a line between the circlet of Pisces and the head of Cetus. So Saturn, you won't be able to miss. That'll be a lovely yellowish looking star in Aquarius, has quite a distinct colour to it. Neptune, on the other hand, cannot be seen with the naked eye at magnitude 7.8, even under a very dark sky. So the best way to locate it would be to use some sort of finder chart, or better still, an app on your phone or tablet, such as Sky Safari or Stellarium. So just like in September, I've also provided a little chart here for you in case you want to go hunting for Neptune's moon Triton. When you're looking for an object such as Triton, it's very useful to be able to work out where to look. So this shows you a simulated view through my 12-inch telescope at around 270 times. And the field of view represented by this circle is around 1/4 degree. So you can see Triton will be quite close to Neptune. It never deviates very far away. And the chart to the left, where it shows the elongations for November, shows you which side of Neptune to look for Triton. So, for example, on the 2nd, it'll be on the southern side somewhere. Won't be exactly south, but it'll be somewhere on the southern side. And on the 5th, it'll be north and so on. So these are the days of maximum elongation of Triton, which occurs approximately every 3 days. And these are the best times to be looking for Triton. You'll have your best chance of seeing it. So to determine the directions in the eyepiece is relatively straightforward. Best thing to do is to, if you have some sort of driven telescope, switch off the drive. And if you have a dob, of course, just stop nudging, and then observe which direction Neptune is drifting, and that will be west. And then if you have a telescope such as a Newtonian with an even number of reflecting surfaces, north will be 90 degrees anti-clockwise to west, and south will be 90 degrees clockwise. On the other hand, if you're looking through a telescope with a star diagonal, such as a Schmidt-Cassegrain or a refractor, then it will be the opposite. So west will still be the drift direction, north will be 90 degrees clockwise, and south will be 90 degrees anti-clockwise, as shown by the red arrow in this diagram. So I think Triton is a very interesting object to look at. It's magnitude 13.5, so it's not super faint, but its proximity to Neptune can make it a challenge. But if you're looking through, say, an 8-inch telescope or above, I highly recommend that you give it a go. So looking at the remaining outer planets now, which are probably best viewed later in the evening after midnight. This shows you the view actually very early in the morning on around mid-month, just before dawn. So we can see Uranus is reaching opposition this month, and that will rise at 9:30 and transit around 1 a.m. And that's located somewhat to the left, probably about 5 or 6 degrees or so to the left of the Pleiades. So you can probably sweep it up with your binoculars. Or if you're under an extremely dark sky, you might even be able to just spot it with your naked eye. In the middle of Taurus is Jupiter. That's transiting at 2:30 in the morning at the moment, and that's already at a massive diameter of 47 arc seconds and shining at a rather bright minus 2.8. And so in addition to enjoying the features on the planet itself, of course, there's all the Galilean moon events, and we'll talk about some of those shortly. And finally, we have Mars, which is rising at around 1 a.m. in the morning, just before 1 a.m. in the morning, and it's transiting at 5 a.m., just before dawn. So the great thing about Jupiter, of course, is even though it's got some wonderful surface features to look at, not the least of which is, of course, the Great Red Spot, is observing all the various events that are caused by the 4 Galilean moons, which form kind of a little solar system as they quite rapidly rotate around Jupiter. So there's 4 main events which are of interest, which are transits, where the moon is actually traveling across the face of the planet, shadow transits, where it's actually the shadow of the moon projecting itself and traveling across the face of the planet. We also have occultations, where the moon goes behind Jupiter, and we also have eclipses, where moons either go into or out of the shadow of Jupiter. And they're perhaps the most spectacular events of all, because the moon essentially either disappears or reappears quite a distance away from the planet itself. So it's as if it just appears or disappears in empty space. So it helps to be able to predict these events, to know when to look for them, particularly eclipses. So I've provided a list of events generated by a Python program that I've developed. And that shows you the predicted events for the next 3 months, so November, December, and also January 2025. And I've provided 2 versions. One version, the front page of which is shown in this slide here, shows you only those events that are visible from Adelaide, and all times are also given in Adelaide time, which is Adelaide Daylight Savings Time, which is UT plus 10.5 hours. And each event also has a specified altitude to give you a rough idea. Obviously, the higher the altitude, the better. Around 30, 35 degrees is probably as high as you'll get. On the other hand, if it's around, say, 2 degrees like that first event, it's probably not worth looking out for because it's too close to the horizon. Also, for our friends that are viewing from overseas, I've also provided a file that shows all events, whether they're visible or not from Adelaide, and the times are given in universal time, so that you can convert them to your own time zone. So here I've just selected just a few events highlighted just for you to look out for. So you can pause the video perhaps and just perhaps make note of these particular events, which I thought would be interesting and well placed for observation. And then you can look up their full details in the provided events file. So what I'd like to do now is just show you in Stellarium a simulation of 2 of these events, just to give you an idea of how to read the events file, and also to give you some idea of what you can expect. So the first event that I would like to talk about is the shadow transit of Io, which is going to occur on the 13th of November. So I've got up here the events file. So I've got the Adelaide version, which is in Adelaide Daylight Savings Time. And I'm going to go down to the 13th. So this shows you the particulars of the shadow transit event for Io. And it's predicted to start at 1:28 in the morning and an altitude of 28 degrees above the horizon, which is pretty much around 30, 35 is as high as Jupiter will get at this sort of apparition. So 28 degrees is very good. And bear in mind, these are only predictions, so they can be out by as little as a minute up to maybe 5 or 10 minutes. So I always recommend, if it's a particularly interesting event that you want to be sure to see, make sure you begin observing at least 10 or 20 minutes before the predicted event. So we can see here are Jupiter's moons. So this is looking at 1 a.m. as it will appear on the 13th. So Io is already quite close to Jupiter. And then as we advance time towards the predicted start of 1:28, we can see that a shadow, a small black dot, has appeared. So that's the shadow of Io being projected onto the surface of Jupiter. And that constitutes the beginning of the shadow transit. So as we advance time along, the shadow will proceed across the disk. And then eventually what will happen is Io itself will now pass in front of Jupiter. So that's listed here as the start of the transit. And that was predicted to occur at 1:59 a.m. So just bear in mind that the shadow transit, although that'll be quite easy to spot at high magnification because it's really just a very dark dot on the surface of Jupiter, Io itself is a much sort of lighter, creamier colour. So it has less contrast, and it's much brighter too. So it'll have less contrast. So it's actually much harder to spot the moon itself as it passes over Jupiter's surface. So as time goes on, both the shadow and the planet itself will proceed across the Jovian surface. And eventually the shadow will reach the far side, which is here at about 3:26, and then at around 3:30 or 3:31, the shadow will then leave the surface. So this constitutes the end of the shadow transit, but the planet, the moon itself, is still in front of Jupiter. And then as time goes on, Io will follow its shadow, of course, and then eventually Io will pass over the other side. So that will then constitute the end of the shadow transit, and in this case that was predicted to occur at around 4:09 in the morning. So shadow transits are, of course, great events to observe, but I think the most spectacular events are eclipses, where the moon either disappears or reappears apparently in empty space well away from the Jovian surface. So the event I'd like to take a look at now is the Europa Eclipse on the 17th, and that starts at about midnight. So I've just scrolled down the data list to look at the particulars of the event, and it's predicted to occur by my program at 11 past midnight. But as you'll see, the eclipse predictions are usually 5 or 10 minutes out. So in this case, we're looking at Jupiter at quarter to 12. So that's about 25 minutes before the predicted start time. So you can see there Europa is already quite close to Jupiter, and then we'll just slowly advance time, 1 minute at a time. So there's 23:50, 51. So we're almost at midnight now. There's 23:55. And what you'll notice is very quickly, over about 30 seconds to a minute, the moon will suddenly start to fade and then disappear. So very spectacular. And it will happen, like I said, quite quickly. So make sure that you don't get distracted, and keep an eye on the moon through the eyepiece as you approach that predicted time. So what's happening now is it's moved into Jupiter's shadow, so that's why it's disappeared from our view. And it's going to actually move eventually behind the planet and become occulted. Now, unfortunately, because we're viewing quite near to opposition on the 8th of December, most eclipses, you won't see both the disappearance and the reappearance. One of them will usually happen, if you like, behind Jupiter. It will be effectively occulted. And you can tell that's the case because you can see here the eclipse end time and the end of the occultation time are both predicted to be the same. In other words, the planet is coming out of eclipse behind Jupiter. So basically all you'll see, if you happen to wait around until the end of the event, so that's predicted to be at 3:41 in the morning. So I'll just advance time. What we'll do is we'll actually see Europa reappear from behind Jupiter on the other side. And there it is there. So that's still quite spectacular to see, but not quite as spectacular as when you see an event, an eclipse end, where the moon actually appears to appear out of empty space. Thanks everyone for joining me in today's show. It's been a great pleasure for me to present it to you. I hope you found it a useful guide to the many fantastic objects that are available in the sky this time of year. In particular, some of the solar system events. So speaking of such, don't forget, link to this video will also be the 2 files describing all of the Galilean moon events from November through to the beginning of February 2025. So until then, bye for now, and I look forward to seeing you in the December show.